Hi everyone, this is the review video for Unit 4.1. So let's go ahead and get started. The first set of directions ask us to use long division to solve these problems. So we're dividing 846 by 17 in the first problem. 17 does not go into 8, so we have to look at 84. And 17 goes into 84 4 times. So we multiply 4 times 17 and we get 68. 84 minus 68 leaves us with 16. Bring down the 6. And 17 goes into 166 9 times. 9 times 17 is 153. When you subtract 153 from 166, you get 13. Now there's nothing left to bring down, so we take what's left over, 13, and put it over what we're dividing by, which is 17. So your final answer is 49 and 13 over 17. Okay, problem 2, same process. We're dividing 9,347 by 6. When you divide 6 into 9, it goes in once. 1 times 6 is 6. When you subtract 6, you get 3. Bring down the 3. Now we see how many times 6 goes into 33, which is 5. Now 5 times 6 is 30. 33 minus 30 is 3. Bring down the 4. 6 goes into 34 5 times. 5 times 6 is 30. 34 minus 30 is 4. Bring down the 7. And 6 goes into 47 7 times. And 7 times 6 is actually 42. And when you subtract 42 from 47, you're left with 5. So there's nothing left to bring down, so we put 5 over what we're dividing by, which is 6. So your answer is 1,557 and 5 over 6. Okay, for problems 3 and 4, we're going to use the same long division process, but now we're going to be dividing polynomials. And the most important thing is that you remember that you're using the same process as we did with just numbers, but there's only a couple differences. One being that what's being divided must be in standard form, including terms with coefficients of 0. So in this case, 6x cubed plus 5x squared minus 9x plus 2 is already in standard form, and there are no terms with coefficient of 0, so we're good to go. And we're dividing it by 3x minus 2. 6x cubed divided by 3x, when you divide those two terms, you end up with 2x squared. And now we're going to take the 2x squared and multiply it by 3x minus 2. So 2x squared times 3x is 6x cubed. And 2x squared times negative 2 is negative 4x squared. We subtract that. 6x cubed minus 6x cubed is 0. And 5x squared minus negative 4x squared gives you a positive 9x squared. We bring down the minus 9x. And now we start over again. We divide 9x squared by 3x. And that gives us a positive 3x. And now we're going to multiply 3x by 3x minus 2. 3x times 3x is 9x squared. And 3x times negative 2 is negative 6x. We subtract that, and you end up with negative 3x. We bring down the 2. And negative 3x squared divided by 3x gives you negative 1. Now we multiply negative 1 by 3x minus 2. Negative 1 times 3x is negative 3x. And negative 1 times negative 2 is positive 2. Subtract, and you end up with 0. So in this case, we do not have anything left over, so we have no remainder. And our final answer is 2x squared plus 3x minus 1. Okay. Problem 4, remember we need to check what's being divided to see if it's in standard form and if there are any terms with a coefficient of 0. In this case, we are missing a term with a coefficient of 0, and that's the x squared term. So we write it as 4x cubed plus 0x squared plus 9x plus 6. And we're dividing by 2x plus 3. 4x cubed divided by 2x is going to give you 2x squared. 2x squared times 2x plus 3 gives you 4x cubed plus 6x squared. We subtract, and you're left with negative 6x squared. We bring down the positive 9x, and now we're going to divide negative 6x squared by 2x. Negative 6x squared divided by 2x is negative 3x. And now we're going to multiply negative 3x by 2x plus 3. So negative 3x times 2x gives you negative 6x squared. And negative 3x times 3 is negative 9x. When you subtract this, you end up getting a positive 18x. We bring down the 6. And now we're going to divide 18x by 2x, and that gives you a positive 9. And we're going to multiply that back through. So 9 times 2x is 18x. And 9 times 3 is 27. We subtract, and you end up getting negative 21. Now, since there's nothing left to bring down, negative 21 is left over, so we take the negative 21 and put it over 2x plus 3, which is what we're dividing by. You always take what's left over and put it over what we are dividing by. I apologize, the divisor. So take what's left over and put it over the divisor. All right, those are all of our long division problems. In the next set of problems, they ask us to use synthetic division when dividing polynomials. So the first thing you have to do in synthetic division is find your a value, what we call our a value. And our a value always comes from when we're dividing by the binomial. I always call it the opposite of the inside, but really it's the x value that makes this 0. So the x value that makes this binomial 0 is 5. So our a value is going to be 5. And we always put it over here in the top left corner in a little box. Then we take the coefficients of what we are dividing and make sure that it's in standard form, including coefficients of 0, just as the same thing as in long division. And we take those coefficients and list them out. So in this case, it's 2, negative 10, 1, and negative 5. Then I leave a little bit of space and draw a horizontal line. All right. The first step is always bringing down the first leading coefficient, which is 2. Then we multiply 5 times 2, and that gives us 10. And we bring that up. And we add together negative 10 and 10, and that gives us 0. Then we multiply 0 times 5, and you get 0. So 1 plus 0 is 1. Then we multiply 5 times 1, and we get 5. Negative 5 plus 5 is 0. Now, the last number, when you're using synthetic division, is always your remainder. So in this case, we have no remainder. So we write it as, our answer is 2x squared plus 0x plus 1. Now, this really just comes out to be 2x squared plus 1, and that is your final answer. Okay, moving on to problem 6. Our a value here is going to be 6, because 6, if you plugged in 6 for x into this binomial, it would make it 0. Or, in other words, it's the opposite of the inside. So we put our a value up in a little box. We make sure that what we are dividing is in standard form, including any coefficients terms with coefficients of 0. And we're good to go. So our first coefficient is 1. Second is negative 7. Continue with 9. Negative 22 and 25. Leave a space and draw a horizontal line. always bring down your first leading coefficient of 1. 6 times 1 is 6. Negative 6 plus 6 is negative 1. And negative 1 times 6 becomes negative 6. 9 plus negative 6 is negative 3. I'm sorry, positive 3, sad teacher. 6 times 3 is 18. Negative 22 plus 18 is negative 4. 6 times negative 4 is negative 24. And 25 minus 24 is 1. And remember, we take the last number and we put it over what's being divised, our divisor. So, in this case, we are going to have x cubed, 1x cubed, minus x squared, plus 3x, minus 4. And we take that last number, which is positive 1, and put it over what we were dividing by, which is x minus 6. That last step is very similar to long division. Whatever's left over, you put over the divisor. Okay? Problem 7, our a value is going to be negative 1. And our coefficients in standard form are 6. And remember, our x squared term here has a coefficient of 0. So don't forget to include that 0, 10, and negative 4. We bring down the leading coefficient, which is 6. Negative 1 times 6 gives you negative 6. 0 minus 6 is negative 6. Negative 1 times negative 6 is positive 6. 10 plus 6 is 16. And negative 1 times negative 16 is negative 16. When you add negative 4 and negative 16, you get negative 20. So, our final answer here is 6x squared minus 6x plus 16 minus 20 over x plus 1. That last number always goes over the divisor. And that is your final answer to problem number 7. Okay? Now, problem number 8, our a value is negative 3. Remember, it's the opposite of the inside, or, in other words, the x value that makes this binomial 0. You put that up in a corner, and then we check our what's being divided, and make sure it's in standard form, including terms with a coefficient of 0, and we're good to go in that case. So we list our coefficients: 1, negative 3, negative 45, and negative 81. Draw a line. We bring down our leading coefficient, which is 1 in this case. Negative 3 times 1 gives you negative 3. Negative 3 plus negative 3 is negative 6. Negative 3 times negative 6 is positive 18. And negative 45 plus 18 is negative 27. Negative 3 times negative 27 is 81. And that leaves you with 0. Okay, so your final answer here is going to be x squared minus 6x minus 27. All right, and that's all of our synthetic division problems. Okay, the next set of problems ask you to verify that the given value for x is a root for the polynomial. In order for the x values given in these problems to be a root for the polynomial, when you plug them in to the function, they must give you an output value of 0. So when you plug in the x, it must come out to equal 0. So let's look at problem 9. We're going to plug in 4 wherever we see x. So 6 times 4 cubed minus 14 times 4 squared plus 10 times 4 minus 4. And as you carefully plug that into your calculator, you end up with a value of 196. Now that is, since it's not equal to 0, this is not a root for this polynomial. Okay, we're going to do the same thing for problem 10. We're going to plug in negative 2 now into this polynomial wherever we see x. So negative 2 cubed plus 3 times negative 2 squared minus 3 times, not negative 3, negative 2 minus 8. when you plug that into your calculator, and if you want to go ahead and practice, you can, you end up with a value of 2. Okay, and since it's not 0, since 2 is not equal to 0, this is not a root. Okay, moving on to number 11. We're going to plug in negative 3 this time. 2 times negative 3 cubed plus 4 times negative 3 squared minus negative 3 plus 15. And that comes out to equal 0. Therefore, the x equals negative 3 is a root of this polynomial. Negative 3 is a root. Okay, last one. We're going to plug in 2 wherever we see x. So negative 3 times 2 cubed plus 5 times 2 plus 6 times 2 plus 2 gives you 0. So therefore 2 is a root of this polynomial. Okay, those are all of the ones where we need to verify if x is a root for the polynomial. Just plug it in and see if it equals to 0. If it does equal 0, it's a root. Okay, the next set of directions says factor each polynomial expression by grouping or sum or difference of perfect cubes completely. Okay, well, on problem 13, we're going to factor by grouping. And what you're going to do is you're going to put the first 2 terms and the second 2 terms together and add them. So you're going to end up with 2x cubed minus x squared plus negative 8x plus 4. Okay, so now we need to pull out whatever we can in this set of parentheses. So in this first set of parentheses right here, we can pull out an x squared. And when you pull out an x squared, you're left with 2x minus 1. Okay, and the whole goal is to get the second set of parentheses when we pull it out to be left with 2x minus 1 also. So we can pull out of this set of parentheses a negative 4 in order to get that 2x minus 1 on this set of parentheses also. Okay, so now we recognize that's what we wanted. We wanted these two things to be the same. So now what we can do is pull out what these two terms have in common, which is 2x minus 1. So we can pull the 2x minus 1 out, and what we're left with is x squared minus 4. So our final answer, because this is a difference of perfect squares, we can factor that also. So you're left with 2x minus 1 times x minus 2 times x plus 2. And that is the original problem completely factored. Okay, let's look at problem 14 now. We can group the first 2 terms together and the last 2 terms together. So we're going to write it as x cubed minus 2x squared plus negative 9x plus 18. We pull out what we can in each set of parentheses. So in the first set of parentheses, we can pull out an x squared. And you're left with, not x cubed, sorry, you're left with x minus 2. Okay, in the second set of parentheses, we want to pull out a negative 9 so we can get another x minus 2. Okay, since these two terms have x minus 2 in common, we can pull out x minus 2, and what's left over is x squared minus 9. And x squared minus 9 is a difference of perfect squares, so we can factor that into x plus 3 times x minus 3. And that is your final answer in that problem. Okay, in 15, we group the first 2 terms together, x cubed plus 5x squared plus negative 4x minus 20 while we're grouping the second 2 terms together. Okay, let's pull out the GCFs. And the GCF of the first set of parentheses is x squared, and you're left with x plus 5. Okay, and what we can pull out of the second parentheses is -4 in order to get x plus 5. Okay, now in these two terms, the common thing is x plus 5, so we can pull out that. And what's left is x squared minus 4. So you get x plus 5, and x squared minus 4 is a difference of perfect squares. So we can factor that into x plus 2 and x minus 2. Okay, problem 16. Same process. We're going to group the first two terms together, 8x squared minus 4x, and then we're going to group the second two terms together, 10x minus 5. We pull out the GCF of the first set of parentheses, and that would be a 4x. And what you're left with is x minus 1. I'm sorry, not x minus 1, 2x minus 1. And then in order to get the same 2x minus 1 when we pull out a GCF of the second, we want to pull out a positive 5. And you're left with 2x minus 1. Okay, these two terms have 2x minus 1 in common, so now we can pull out 2x minus 1, and what's left over is 4x plus 5. And that is your final answer. Okay, so now we've done factoring by grouping. In these next problems, we should recognize that we have the sum or difference of perfect squares. So here, x to the 6th is a not perfect squares, perfect cubes. X to the 6th is a perfect cube, and 125 is a perfect cube. So my a value is going to be the cube root of a to the 6th. So the cube root of a to the 6th is a squared. And the cube root of 125 is 5. And since we have a sum of perfect cubes, we're going to use the sum factoring formula that we know, which is a plus b. Remember, the first sign always matches, times a squared minus a times b plus b squared. And all we do now is plug in the a and b values that we found. So a is a squared plus b, which is 5. And then a squared, when we plug in our a value of a squared squared is a to the 4th. And then minus ab, which is a times b, which is 5 a squared, plus b squared, which is 25. And that is your final answer for 17. Okay, in problem 18, we have a difference of perfect cubes. So the perfect cube 8x cubed, when we take the cube root of that, we get an a value of 2x. And when we take the cube root of 27, when you take the cube root of 27, you end up getting a b value of 3. Now, the formula for the difference of perfect cubes is a minus b times a squared plus ab plus b squared. Notice the difference between the factoring formula for a difference of perfect cubes and a sum of perfect cubes over here. You need to make sure that you know those for your test tomorrow. So we just plug in from this point. So a is 2x, b is 3, so 2x minus 3 times a squared, which is 4x squared, plus a times b, so positive 6x, and then b squared is 9. Okay, now we're going to move on to problem 19. Here we notice that they have a GCF, and you always have to pull out your GCF first. And the GCF here is 5, so we're going to pull out a 5 from this problem, and you're left with a to the 9th plus 64. 320 divided by 5 is 64. That's where that number comes from. Okay, so now you should notice that we have a sum of perfect cubes. And the cube root of a to the 9th is a to the 3rd. So our a value is a cubed here. And the cube root of 64 is 4. So our a value is a cubed and our b value is 4. So since it's a difference of perfect cubes, we use the difference of perfect cubes factoring formula. Oh, I'm sorry, it's the sum of perfect cubes. So it's going to be a plus b times a squared minus ab plus b squared. And don't forget to bring down that 5. Okay, so now we just plug in from this point. It's going to be 5 times a cubed plus 4. And then a squared is really a cubed squared, so you get a to the 6th, minus a times b, which is a cubed times 4, so 4a cubed, and then b squared is 16. And that is your final answer for this problem. Okay, last one. It looks like we have a GCF in problem 20 also, and we have to pull out 2x squared. That's our GCF, and when you pull out 2x squared, you're left with x cubed minus 8. Okay, and x cubed minus 8 is actually a difference of perfect cubes. So the cube root of x squared is x, and the cube root of 8 is 2. So we bring down the 2x squared, and we're going to use the difference of perfect cubes factoring formula, which is a minus b times a squared plus ab plus b squared. So we just plug in from this point, 2x squared, our a value is x, minus 2, which is our b value, times a squared, which is a squared plus ab, which is 2x, plus b squared, which is 4. And that is your final answer. And those are our factoring polynomial expressions by grouping or sum of difference of perfect cubes problems. Important things to remember are when you're doing your sum or difference of perfect cubes is to pull out the GCF first. And then if you see a difference of perfect squares, you need to make sure that you factor those out. Okay?